Because the crew will cement the casing string in place, they also have to install some special devices on the string, which come into play during the cementing operation. The guide shoe is a heavy steel and concrete fitting that the crew makes up on the end of the first casing joint to go in the hole. It guides the casing past rough spots and ledges in the wellbore. It also has an opening in the end. Drilling mud enters this opening when the crew runs the casing into the wellbore. Later, cement will come out of this opening on its way into the annulus. Usually, the crew installs a float collar in the second or third casing joint run into the wellbore, or sometimes they install a float shoe. Whether a float shoe or a float collar is used, each has a one-way valve in it. Fluids can flow downward through the valve, but cannot flow upward past the valve. The float collar or float shoe keeps drilling mud from entering the casing string as the crew runs it into the hole. Keeping the casing empty of mud allows the casing to partially float in the mud, that is, in the annulus, just as a hollow steel boat floats on water. Letting the casing float cuts down on stress and fatigue on the hoisting equipment. But the crew cannot keep the casing totally empty of mud. If they did, the hydrostatic pressure of the mud in the annulus could crush the casing. So from time to time, the crew puts mud into the inside of the casing from the surface to offset hydrostatic pressure. The float valve also holds the cement in place once it is displaced into the annulus. Otherwise, it would U-tube back into the casing. On various joints of casing, crew members also install centralizers. Centralizers keep the casing from leaning against the side of the hole. In other words, centralizers keep an opening between the outside wall of the casing and the wall of the hole. Centralizers reduce drag and differential sticking while running the casing. Drag is resistance to motion caused by the casing contacting the wellbore. Differential sticking happens when the casing contacts a permeable formation in the wellbore, and the pressure in the hole is greater than the pressure in the formation. The higher hole pressure tends to hold the casing in contact against the area of lower formation pressure. Keeping the casing off the wall of the hole also ensures that cement will surround the outside of the casing and bond it securely to the hole. In order for the cement to fill the annulus properly, it is important that the casing string be as centered as possible. Click on the button marked Add Centralizers to see the effect of centralizers. Here you see a casing string that has 0% standoff. This means that it's up against the side of the wellbore. Change the standoff to see how standoff affects cementing. This string is at 50% standoff. As the cement flows up the annulus, it will fill the wider side of the annulus more quickly. This leads to an inadequate cement job. This string is at 75% standoff. 67% standoff is the minimum acceptable standoff. So at 75%, this cement job is adequate. However, it is not optimal. Here, the string is at 100% standoff. That means it is perfectly centered. At 100% standoff, the cement flows evenly up both sides of the casing, leading to a good cement job. Another device that helps ensure a good bond of cement to the hole is a scratcher. Depending on the wellbore's characteristics, crew members install several on the casing string. Just before they pump the cement into the casing and hole, they rotate the casing string, or move it up and down, that is, reciprocate it, depending on the type of scratchers they install. In either case, the scratchers remove wall cake left by the drilling mud during drilling. Removing the wall cake, solid particles in the mud that stick to the wall of the hole, helps the cement bond better to the hole. Let's see what happens when the cement does not bond properly to the hole. Click on the buttons to compare a good cement job to a bad one. The cement in this wellbore is properly bonded. The production fluids enter the casing through perforations and flow up the casing to the surface. Fluids and gas from other formations are not allowed into the well. The cement in this well bore is not properly bonded to the hole. This creates channels that allow fluids and gases from formations besides the one being produced to enter the annulus. This is undesirable, since the well and other formations can be damaged.